everybody, and welcome back to the Bioenergetics of Mixed Martial Arts. I'm Dr. Jason Gillis. So this is session 2, but what we learned about in session 1, the last session, was the essentials of energy expenditure, and that was all about how energy is stored in the human body and the importance of this molecule called ATP in powering muscle contraction. In this session, we're going to talk about a particular energy system, the ATP-PCr system, and it's really responsible for generating explosive energy in the cage, so it's pretty important. In sessions 3 and sessions 4, we're going to talk about 2 other energy systems, anaerobic glycolysis and then aerobic metabolism. In sessions 5, we're going to talk about maximal aerobic fitness. In session 6, we're going to talk about anaerobic threshold. And then we're going to get really practical in sessions 7, 8, 9, and 10. We're going to talk about low versus high intensity training. We're going to talk about how you train an energy system. We're going to give you a lot of specific workouts there. In session number 9, we're going to talk about periodization, a little bit of theory. And then in session 10, we're going to show you how you kind of put it all together. So welcome to session 2. In this session, we're going to focus on the ATP-PCr system. I've got some learning objectives for you here. The first thing, I want you to understand what the ATP-PCr system is and how it works. I want you to be able to identify training objectives for when you train this system, and I want you to be able to recognize performance adaptations that result from training this system. And finally, I want you to have an appreciation of what causes fatigue when you really work in this system. So here's a little outline. This is what we're going to cover in this lecture. First, we're going to talk about the characteristics of the system. Then we're going to talk about how the system works. We're going to give you some training objectives. We're going to talk about performance adaptations. We're going to finish by talking about fatigue. So what are the key characteristics of this system? Well, number 1, it's anaerobic, and that means that it doesn't require oxygen to produce ATP, and that's important. It supplies ATP at a very fast rate, so it's a very high power system, but it relies on this molecule called phosphocreatine. And you may recognize the last half of that, creatine, because it's basically influenced by the supplement creatine, which I'm sure that you've heard of or maybe even use. The thing about this system is it cannot resupply ATP indefinitely. Really, it's going to be depleted in as quick as 15 to 30 seconds of intense exercise, so we need a way to resupply ATP, and it's going to come from another system. So let's give you a little overview, a simple overview on how this system actually works. So you've got a molecule of phosphocreatine, which is denoted by PCR, and that will break apart and donate its phosphate molecule to ADP, which generates 1 molecule of ATP, and it doesn't require oxygen. It's anaerobic. So let's show you. We've got our ATP molecule here. And I didn't mention this before, but there's a special enzyme that breaks apart ATP. It's called ATPase. And in general, that's how you know we're dealing with an enzyme, because it ends with that last term ase. So ATPase is the enzyme that breaks apart ATP. And as we talked about, that releases energy and that allows muscles to contract. Now, just as a little aside, bound in ATP is hydrogen ions. And when they split apart, when that third phosphate is broken, then you have a release of this phosphate, and you have a release of hydrogen ions. And remember, we're talking about inside the muscle here. So when ATP breaks apart, it releases a hydrogen ion and a phosphate, which we're going to call inorganic phosphate. That's why the I is there, right over here, inorganic phosphate. So we break ATP down, we have this buildup of hydrogen ions and inorganic phosphate inside the muscle. So what's the next thing that happens? Well, we have these molecules inside the muscle called phosphocreatine. And so it's bound to 1 phosphate molecule and 1 creatine molecule. Together we get PCR, or phosphocreatine. So what happens? We have a special enzyme called creatine kinase that splits apart phosphocreatine. And what that does is that allows this new phosphate to be bound to ADP to create this new ATP molecule. And then a hydrogen ion will be removed from the muscle and it'll go back into ADP to create ATP in the whole process. And then eventually, if we rest, if we wait long enough, then these inorganic phosphates will rebind to creatine. And what will happen is we're back to where we started before. There's a couple more points that I want to mention here. As I said, the ATP-PCr system, it's not unlimited. We only have a small amount of phosphocreatine. So let's talk a little bit about that pool. And incidentally, if you supplement with creatine, then you can increase this pool. As I said, the phosphocreatine pool is depleted in as little as 15 to 30 seconds of maximal activity, and it can take up to 5 minutes of rest to restore it. So what ends up happening here is the same thing happens as we previously described. ATPase splits apart the inorganic phosphate. That will cause an increase in hydrogen ions and inorganic phosphate around the muscle. But the thing to remember is we've got this big pool of phosphocreatine, and this is going to be happening very, very fast. You're going to be breaking down a lot of ATP. And as a result of this rapid breakdown of ATP, you're depleting the pool, for one thing, and you're seeing this large buildup of inorganic phosphate in the muscle and hydrogen ions in the muscle. And this can have a negative effect on performance. It can impair the contractile function of your muscle, and it's another probable cause of fatigue in mixed martial arts. Okay, I'd like to draw just a little picture to try to illustrate this point, just a little bit. Okay, let's draw just a little picture here. We're going to draw vertical axis, and we're going to say that this is the percent of resting value. So let's say that that is going to be the percent of value. And all the way up here, it's going to be 100%. And let's go down to 80, 60, 40, 20, and 0. So we're going up here. And then on the horizontal axis, we'll draw another line here, and this is going to be time measured in seconds. And let's just go for 2 seconds, 4, 6, 8, 10, 12, 14. So we know what we're looking at here is the ATP-PCr system. What I want to do is I just want to draw what happens to the amount of ATP in your body during this time. So we'll just draw a little line. That's about what happens to ATP. So those are your stores of ATP in your body. So in as little as 14 seconds, you're seeing your ATP stores kind of a little bit high. They drop very quickly, and then they're preserved, and then they start to drop a little bit. What I want to show you next is what happens to the body supply of phosphocreatine. Okay? It's going to look something like this. Okay? So this is phosphocreatine. So the thing that I want you to know is right now you have a lot of phosphocreatine, right? And it's dropping rapidly in the first couple seconds of maximal physical activity, to the point where you get to around 14 seconds or so, it's nearly totally depleted. And look what happens to the amount of ATP that you have after 14 seconds. It's nearly depleted as well. But you see, what's allowing this to stay elevated, the amount of ATP? It's this rapid reduction in phosphocreatine, which, remember, it's donating these phosphates up to ATP, right here, which adds on this other phosphate, which increases the ATP pool. But if you're exercising maximally, that pool is going to continue to drop down. So I hope this gives you a little bit of a view on what's happening with ATP. Now let's get back to that lecture. Okay, so we're going to be developing this figure as we move through this lecture, this session, and other sessions as well. So what we're looking at is the percent contribution to the total ATP supply over here, ranging from 0 to 100%, and this is in minutes of exercise. So this time we're looking at, it's about the length of a round, so we're looking at 5 minutes in total. So let's have a look at what happens to ATP here, and we're going to build on this figure with all the other energy systems we're going to have on this figure. So you can see that you're starting off with a very high quantity of ATP, but the ATP-PCr system, it's really only going to be providing maximal effort, maximal contribution to ATP just in the first couple seconds or so. And then after, if you max out here, then you're going to have a nearly reduced pool of phosphocreatine, and it's going to take you some time to resupply it. There are ways though, there are ways. So what are the main training objectives here? Well, number one, you want to be able to increase the capacity of the ATP-PCr system. You can do this through training, but you can also do this through supplementing with creatine. And what you do is you're increasing the number of phosphocreatine molecules there, and that can extend the capacity of the system. You also want to improve phosphocreatine resynthesis. So after you've depleted the pool, you want to be able to improve your ability to get that pool back. And there's a couple ways you can do that, the least of which is having a very strong and highly developed anaerobic and aerobic energy system as well. What sort of performance adaptations can you expect to see if you train the system properly? Well, you're going to expect to see improved power of single efforts, maybe takedown attempts or prolonged grappling or single strikes. But you're also going to see improved power of short combinations, short explosive combinations. But what about fatigue and the ATP-PCr system? Well, there's really two sources of fatigue, at least. One, you're going to run out of phosphocreatine, and two, you're going to see a buildup of metabolites. That's inorganic phosphate or hydrogen ions. Either way, in both cases, you're going to either stop exercise if you totally tap out the capacity of the system or if you have a huge buildup of metabolites, or you can lower your exercise intensity and continue exercising and get most of your ATP from another energy source. All right, let's give you a summary here. Number one, the ATP-PCr system, it's responsible for powering short efforts. So your training objectives, they're to increase the system capacity and phosphocreatine resynthesis. In terms of performance adaptations, if you train the system properly, you're going to see improved power of single efforts and short combinations. And what's going to cause fatigue in the system? It's going to be phosphocreatine depletion. It's also going to be a buildup of metabolites. So here's some references if you want to explore those further. Please feel free to. But that's it for this lecture. I hope you got something out of it, and I look forward to seeing you next time. Take care.